4. The valency is 4, which means that how many covalent bonds does carbon need?
4.
4. So that's exactly what it does in the case of diamond. So every carbon atom is linked to 4 other carbon atoms by strong covalent bonds. So these 4 are carbon. And then each of these is again further, it is linked to 4 other carbon atoms. Then each of these is linked to like 4 other carbon atoms. Okay, so that way it just goes on and on until, there's like a large network of carbon atoms. So this also has 4 other carbon atoms attached. This also has like 4 other carbon atoms attached. So if you take this, you have 1, 2, 3, 4. If I consider this, I have 1, 2, 3, 4. This is attached to 1, 2, 3, 4. That way it just like goes on. And that's how the whole structure of diamond is formed. Okay. And that is the reason for its hardness. So if you look at the physical properties of diamond, like what comes to your mind? One is it's pretty hard. What else?
Shine.
Shiny, yes. What other words can you use for it? What is the optical property related to that?
Very reflecting.
Reflective or
Transparent.
मतलब glass cube जैसे नहीं है ना? It's not completely transparent also.
It has a high refractive index.
Refractive index, correct. High refractive index, that's the optical property. What else do you know about diamond? Is it a conductor of electricity or not?
No.
I guess it's not.
No.
Some bad.
It does not conduct electricity.
Also, like there's a I've heard that if you put your tongue or lick a real diamond, you can die.
No, if you swallow it, you will die.
That also depends. If it's like a really tiny diamond, it may just like go through your digestive system and be done. But if you lick it, not pure diamond, because think about it, carbon hi hai na, and you're also made of carbon only. So yeah.
Well, then, ma'am, it was
But ma'am,
just
Sorry, yeah, I didn't hear you, Arna. What were you saying?
like in the movie I saw, I couldn't understand it then, but it is probably like just to put some drama in it.
Or that could have been poisoned, because that's kind of how people test the jewels and all, right? So must have just coated it with something else. Swayam, what were you saying?
Well, I was saying if it's medium-sized diamond, then I guess it will kill a person.
There's a possibility, and it also depends on how it's cut, right? Like if it has sharp edges, it's going to like pierce your insides. That's not good for any human being.
Ma'am, how can you even mistakenly swallow such a large diamond? You can see it, right? So
Babies
you're only
kids swallow all sorts of things, right? That's why you need to like take care of them.
yeah, but no one's gonna have a medium-sized diamond just laying around except the rings.
Yeah. Anyway, back to this. So a lot of these properties are a result of what its structure is like. Okay, so I'll just quickly discuss graphite ka structure also. So by contrast, like diamond mein kya ho raha hai? Every carbon atom is linked to 4 other carbon atoms. Don't note it down. So again, I'll show you the chapter notes. It's put in very nice sentences and all. I'll give you a better way of a presentation. So focus here for now. Graphite ka structure, by contrast, what happens is, in graphite, each carbon atom is linked to only 3 other carbon atoms. यहाँ पे 4 carbon atoms से link है, यहाँ पे it's linked only to 3 of them. So this one has 3 more carbon atoms. Then this also is linked to 3 more carbon atoms. This is also linked to 3 other carbon atoms. So it is so like through this sort of a linking, you can observe two things. One, this forms kind of like this flat structure, flat hexagonal structure, this whole network. Diamond is, it's difficult to draw here because it's a 3D structure. Like the four of them exist in like all the directions, is it? But in the case of graphite, it consists of flat hexagonal rings ka network.
Layers.
Yeah.
Layers.
Yes. And each of these hexagonal network is arranged in layers, like one on top of another. Okay. So these two are like characteristics of graphite, and that is where you get all of the properties and uses of graphite from. So graphite is, first property, it is soft and slippery. Why? Because it's made up of layers. So these layers are not held by covalent bonds. Graphite may covalent bonds only, like each carbon atom has only 3 covalent bonds. So iske upar jo bhi hai, the second layer of graphite, they are held together by weak van der Waals forces. Have you guys heard of van der Waals forces in any of the earlier grades, 6th, 7th, 8th? Right? No? Okay. So just like how you have forces, right? Like you have electric force, magnetic force, gravitational force, ye sare hai na? So similarly, atoms or molecules ke beech mein, by default, van der Waals forces is something that they always have. So you have any species, like any two atoms, molecules, ions, jo bhi hai, any two particles, they both will have van der Waals forces by default. Like it's just there. Acha, we have two atoms, matlab unke beech mein van der Waals forces to rahega hi. And it is a very weak force, like gravitational force. Like you need a large amount of mass to see the attraction. Magnetic force, electric force is pretty strong by comparison. Like you can see it, attracting each other or repelling each other. But van der Waals forces is one of the weaker forces. It exists by default. So apart from van der Waals forces, if it's like two ions, then extra like electrostatic forces rahega, ya fir dipole attraction rahega. Like everything else is after it. But this is something that's just there by default between all atoms. So graphite ka each of these hexagonal ring network layer, this whole sheet is being held together by weak van der Waals forces. So because it's a weak force, it's easy for the layers to slip and slide over one another. Okay, so that is why graphite ends up being soft and slippery. What other property do you know about graphite? Yeah. What else do you guys know about
It's
graphite?
a good conductor of electricity.
Correct. And why does it end up being a good conductor of electricity?
Exchange of ions.
Huh?
Movement of electrons.
Movement of electrons, yes, but can you be a little more clearer? Because carbon is not a metal, no? It won't give away electrons like that. So kahan se aa raha hai?
Like the van der Waals forces are like pretty weak, so they slide over each other, so the electrons also move.
They slide over each other, okay, but wo electrons kahan se aa raha hai? Like, why is that not happening in diamond or any other, like other non-metals also? What is special about graphite specifically? Where are those electrons coming from? Come back to, yeah, Megha, what's up?
Ma'am,
Huh?
I'm not sure about my answer, but maybe like so a carbon atom needs to form like 4 covalent bonds. So since the fourth electron of like each carbon atom, it's like unbounded. So that's why the graphite conducts electricity.
That is exactly 100% right. So diamond में क्या हो रहा है? All the 4 valence electrons are bonded to other carbon atoms, right? So इसमें there are no free electrons, ends up not conducting electricity. Graphite में, as Megha said, so each carbon atom is bonded to 3 other carbon atoms. लेकिन carbon के पास है total 4 electrons. So the 4th electron which is free, usually, I think Aryan, that's what you were getting towards. It kind of exists between the layers of graphite. But again, because the force is weak, that 4th electron is free to move, which is where conductivity comes from graphite ke liye. Okay, so you needed to mention the 4th electron. Like graphite mein carbon only forms 3 covalent bonds. Every carbon atom only forms 3 covalent bonds. So the 4th electron is free. It's free to move around. And that's the free electron that you get for conducting electricity. Okay. So now, just to give you guys a better idea, look at the 3D structures. Yeah, so this is the structure of diamond. Yeah, just rotating it. So you see how stiff it is, how ordered it is. It's almost not exactly cubes, but yeah, almost. It's like a regular shape to it, right? And you can see here, let me get a good angle on this. So focus on this particular carbon atom. So there's like 1, 2, 3, 4 bonds. Similarly, if you look at this one, so has 1, 2, 3, 4. So you pick any atom in this whole structure, you will find that it is bonded to 4 other atoms. Okay, so that is the speciality of diamond ka structure, and that's what gives rise to its all of its property: hardness, not conducting, like all that stuff. Refractive index, like even its crystalline form. And by contrast, if you look at graphite, yeah, graphite is made of individual layers. If you look at the top view of it, see that it's hexagonal hai pura. Hexagonal links, and hexagon matlab, yeah, so each sphere here, each circle is bonded to 3 other carbon atoms. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Graphite, that's the whole reason why you're able to write with your pencils also. So every time you're writing, you're putting like a few layers on the page here. So when I write, so the writing happens because there's like a few layers of graphite here. So that comes because, you know, van der Waals forces, weak forces, it's easy for the layers to, you know, detach from one another. Okay, that's structure of graphite. And because of its structure, that shapes its properties, and that's how we are able to use it in all these different ways. Okay. All right. So now note this down to summarize. Yeah, covalent bonding media, diamond, graphite. There you go, allotropes of carbon. So diamond properties: colorless, transparent, high refractive index. It's extremely hard, does not conduct electricity. Hard matlab high melting boiling point, high thermal conductivity. Why? Because of its structure, linked to 4 other carbon atoms, rigid 3D network. These are the main key points that you have to know. Highlight them. So linked to 4 other carbon atoms, this is important, rigid 3D network. So when we're talking about structure of diamond matlab, these 3 key points have to be there. You need to mention those. So let me know once you finish writing about diamond, then we'll scroll and can write about graphite. Cool. Yeah, so based on the structure, you have these properties, opaque, smooth and slippery, and good conductor of electricity. So uske basis pe the property, the uses also will follow. So which property of graphite is used over here, where it's used as a lubricant for parts of machinery? So which property is used here?
The slippery one.
Yes, it is soft and slippery, so इसलिए it can be used as a lubricant. Used for making lead pencils, like what part, what property, or what structure?
The smooth.
Can you repeat that, Ashia?
You said it's smooth.
It's smooth, yes. What else? Silk is also smooth, but you don't see pencils made out of silk, right? What other property? What else? Anyone? Think about it, guys. Like when you're writing, what is
Ma'am, I think
stick onto the book, pages of the book, like when you apply pressure, so one of those hexagonal layers, like
layer? Yes, correct. What else? Arna, you were saying? Also, the fact that it's dark, it's black and opaque, which is very important when you're writing, like dikhna chahiye whatever you've written, right? So yeah. Used for making electrodes, what property, Shana?
Electricity, it conducts electricity.
Correct. So it conducts electricity, so it is good to be used as electrode. So specifically when you want an inert electrode, like if you take a metal, is a possibility that the metal will ionize, metal may react with one of the products and all that. So when you don't want that to happen, graphite is a good choice. Like inert electrodes ke liye, people usually go for either platinum electrodes or graphite electrodes. So chloralkali process mein, what you use is graphite electrodes. But when you want to refine it, like collect a metal over another metal rod, like when you're refining copper, things like that, then you take that particular metal as your cathode. Otherwise, go with graphite. So that's diamond and graphite. Now coming to the third, this thing, Buckminster fullerene. So fullerene, they are more recently discovered allotropic forms. Recently in the sense, like around 1900s may discovered were. I don't remember the exact year, but it was this thing. It's also known as C60 because, show you the structure of that. We have graphite. Yeah. So this is the structure of Buckminster fullerene. So based on what it looks like, they're also called buckyballs.
it looks like a football.
And C60, yeah, that's exactly why it's called buckyballs. In fact, it's not just the shape that looks like a football, the structure itself is like a football. How familiar are you guys with football? Like, kaise dikhta hai? What are the properties of the football?
Ma'am, like my football, which I used to have, had those same like hexagonal and pentagonal.
That is correct. There's a fixed ratio of kitne hexagons hona chahiye, kitne pentagons hona chahiye, right? So this structure also is basically has the same thing. You see that there's hexagon and there's like pentagon. So every pentagon is surrounded by hexagon that way. Okay. So that's the reason it's called buckyballs, very similar to what your football looks like. It like the first one that was identified had 60 atoms, like each of these balls is made of 60 atoms of carbon. So it's also called C60. Okay. So the name Buckminster fullerene is actually comes from a person's name. So that person's name, I'll just show the chapter notes. These are written there. Yeah. So the allotrope is named after Buckminster Fuller. So this is the name of a person who is an architect. He has nothing to do with chemistry. Okay, he's an architect. But the reason why it's named in his honor is he designed something called a geodesic dome. So it's a specific type of building, you can say. This is what a geodesic dome looks like. Do you see the similarities with the carbon ka structure, the ball-like structure? So in his honor, because uska structure looked very similar to what this guy designed, it was just named after him as Buckminster Fullerene. Fuller is his name. Because it's a carbon ka compound, just call it fullerene. That's it. So this exists in liquid state usually, and it's relatively new. So like people are still studying it, figuring out what you can do with it. As far as I know, I think it's used as a solvent for like other reactions and things like that. Otherwise, yeah. Okay. So these are the allotropes of carbon. This is how elemental carbon exists. Now, coming to the other aspect of carbon, so it's carbon and its compounds, right? Now let's talk about the compounds of carbon. Can you give me examples of different compounds of carbon that you know of? Yeah, one by one, quickly. What all compounds of carbon? Give me an example, any random compound of carbon without.
CO2.
CO2 is the simplest one. Or yeah,
It's methane.
methane. What else?
Ethane.
Ethane, okay. Or
Ma'am, just for the sake to name something fancy, carboxylic acid.
carboxylic acid. Yes, we'll take it. Two people on chat. Dakshinya, okay. CaCO3, okay, carbonate, it exists in the form of carbonate. Okay. Let's call it carbonate ion, CO3 2 minus. So Na2CO3, CaCO3, all the carbonates covered here. Swayam, Shana, you guys, examples? Swayam and Shana, you guys there?
Yes, ma'am.
Yes,
One
ma'am.
second.
Anything like what? Okay, what is made of carbon? Just think about it and give that answer. You just need a compound of carbon. Dakshinya sent, that's a very good example. Sugar, C6H12O6. Everybody has given an example. Swayam, Shana, you guys still waiting.
Is ethane mentioned? Because even ethane.
Yes, I've written all of it here. Are you paying attention?
Yes, ma'am.
So, Swayam, you're not paying attention. Look at the list I've written here. Did you even hear what others said? Megha, yes. Acetic acid is a type of carboxylic acid. Yes. Good.
Will ethanol count?
Ethanol, yes, absolutely. Ethanol ka formula C2H5OH. Actually, C60 is like we just said that was elemental carbon. It's an allotrope of carbon. Now we're talking about compounds of carbon. Like other atoms ke saath, what are the examples?
Hydrogen carbonate.
Huh?
HCO3, like hydrogen carbonate.
H2CO3 वो तो ठीक है, carbonate ion में I've included it. Fine. Have you guys
CH3.
CH3 is incomplete. Carbon का valency 4 है ना? So one more something should be here. Good. So I am mentioned, I haven't gotten anything from you guys yet.
I said
Ethanol, I'm
ethanol.
sorry, I'm so sorry. Ethanol is said by you. So Swayam, you're the only one. क्या हो रहा है? Few others. Let's see. Ethanol, then have you guys heard of urea?
Yes, yeah.
You should have, like, life process khatam kiya na. So urea is also a compound of carbon. Iska formula is CONH2 taken twice. Okay. Sugars, amino
Carbonic acid. Yeah, carbonic acid.
carbonic acid, yes, H2CO3, I've written it as carbonate ion. So all of that. Anything that contains this ion, consider it covered. Okay.
Acetic acid is, you have written, okay.
So we've barely scratched the surface of carbon atoms. Beginning of the chapter, we discussed that all the plastics are made up of carbon. So plastics, matlab PVC is an example. Like full form of PVC is polyvinyl chloride.
If plastic is there, so like ethylene glycol, like will it?
Ethylene glycol is a compound of carbon, yes. Polythene also is polyethylene. That's also a carbon compound. Ethylene glycol is not a plastic, but it is a compound of. So ethylene glycol is it's made of 2 CH2 groups, and you have an OH here and an OH here. It's ethylene glycol. Okay, so there's like a lot of compounds made up of carbon. Like we've barely scratched the surface here. So Dakshanya, yes, I'm just asking you to name the specifics, all the things that are made of carbon. I started with that. So give me those things, names. That's it. So if you observe what's happening here, we see carbon is bonding with oxygen, hydrogen. You have compounds containing single carbon. You have compounds containing 6 carbon atoms. Carbons forming bond with nitrogen also. Chlorine also. Multiple carbon atoms ke saath, like ranging from, amino acids, plastics these are carbon compounds that contain like hundreds of carbon atoms. So what is so special about carbon that all of this is possible with it? Like, why do we not have these sort of compounds where, I don't know, chlorine is the backbone or oxygen is the backbone of it? Why carbon only? So the special nature of carbon, carbon is special because it has 2 specific properties. So one is catenation, and second is its tetravalency. So these are the 2 properties that make carbon extremely versatile. So these sound like new words to you guys. So let's see what each of them means. So you can note down the definition for catenation. So this part right here. So catenation is the property of self-linking of atoms. Again, I'll highlight the important points. So self-linking of atoms of elements like carbon through covalent bonds to form long